Down counters. Now as up counters count from 0 upwards, the down counter starts at high values, and then instead of adding 1, they keep subtracting 1 with every clock pulse that they receive. Now the JK down counter, as an asynchronous, we can see that the J and the K's are all connected to a high value, and then we've got the clock going into our first flip-flop. The NOT Q feeds into the second clock, and the second one's NOT Q feeds into the third clock input. Now if we accept that we're starting at 1, 1, 0, that means that this Q, or this NOT Q, is a 1. That means that this is a 0, and because we've got 1 on all the inputs, these are ready to flip or toggle. So our first is 1, 1, 0. With a 1, 1 there, when it receives the clock pulse, when it receives the falling edge trigger, this first flip-flop is going to flip, which in turn is going to turn this Q into a 1 and the NOT Q into a 0. That 0 feeds in there, which means this is going to toggle because it's the falling edge, which means this one toggles, turning that into a 0 and this one into a 1. And that one over there is rising, so that one's going to stay as it is. With the next trigger pulse, we are going to change. We're going to see that because of the 1, the falling edge on this pulse is going to turn that one back to a 0 because it's in toggle mode. So that 1 becomes a 0, that 0 becomes a 1, that's a rising edge. So this JK is going to stay the same. That one's going to stay the same, which in turn means that one's also going to stay the same. Stay the same. There we go. With the next trigger pulse, this flip-flop again toggles, which means that becomes a 1, this becomes a 0. We've dropped, so this one's going to toggle, which means this is going to become a 1, and that's going to become a 0. Because that is dropped, this one's going to toggle, which in turn gives me that. So the next clock pulse should then result in 0, 1, 0. With the D-type counters, let's start at the same value where we've got 1, 1, 0. We can see that this NOT Q feeds into there, so as a result, because that is a 0, this is a 1 feeding in there. Because this is a 1, that is a 0 feeding in there, so this one is in the hold state. Because we've got a 1 there, that's a 0, which means that flip-flop is also in the hold state. So we're starting off with 1, 1, 0 on this flip-flop, or on this counter. So when we receive our pulse, this is going to toggle because of the 1. So that's going to become a 1 there, which means this becomes a 0. When we look, this one feeds in there, which means it's going to hold, no, it's going to toggle, and that one feeding in there is not falling, so it is going to hold its state. With the next pulse, we've got a toggle occurring there because it's dropped, which makes that a 0. Then that 0 feeds in there, so it doesn't toggle, and that one feeds in there, which means it stays the same because the one hasn't changed. With the next clock pulse, that feedback is going to toggle because it's a 0. I've got a 1 feedback, so the pulse sends the 1 to the output, turning that back into a 0 with a 1 there. That 1 in the toggle in the switch there will toggle this output into the that's a 0 from the previous state, so that 0 will now be fed through where the switch toggles it. Because it dropped, that 0 will now be fed to the output, and when we receive the next clock pulse, our output should change to 0, 1, 0. Now, counters can be designed specifically so that the up and down can be selected, and I will post 2 circuits. You're welcome to pause for the JK up-down contactor as well as the D-type flip-flop up-down counter.